I will welcome Jaworski to talk about STAARK Luximpulse robotic arm for lunar resources utilization. Jaworski, are you there? Oh, even better. I'm so sorry, I didn't know.
Good to see you, Lisa.
Thank you so much for being in person. Oh my God.
I do not have a long distance from the office here, so good to see you, everyone. Not a lot of people, but I must say, great to see you after, I wanted to say so many years, but actually it was a year. All right, I think let's start. Apparently we have fewer people in the room, and I think 200.
Oh yeah, on the chat right now about 200, yeah.
All right. Okay, I will talk a little bit about what Made in Space is doing, and right now actually what Redwire is doing, since we are going through some changes, and actually what we do here in Luxembourg and what we are planning to do later, a little bit in the context of space resources, but also in general robotics. So probably a lot of you know Made in Space. We are initially we were a company that was oriented on manufacturing in space. First object ever 3D printed on onboard International Space Station, and then several more, a lot of research on board ISS. And then go step by step to building technologies and building capabilities and expertise to one day build large structures and large infrastructure in space. Since this is a new frontier, we believe, for general development, big telescope, big antennas, solar farms, this is something that would push space industry forward. So over 10 years of our development of in-space manufacturing capabilities, we won a few years ago a very big contract, Arkinow, that will demonstrate that actually how to use commercially advancement of in-space manufacturing, where in Arkinow spacecraft we are building in US, we will, for commercial purposes, we will 3D print very long boom to roll out solar panels and enable very small ESPA-class satellite to have 10 times higher budget, power budget than typically when you have deployable solar panels. So imagine how much you can achieve by payload, by processing units, by your antennas having 10 times budget. This is a game changer. And during this development, actually, when we had a very strong expertise, I believe we have a strong expertise in manufacturing, we found out that the key element for this is actually having robotics expertise, robotic subsystem that is second the most important after subsystem of manufacturing. So we were trying to find out, we were doing studies, make or buy. We found out that it's great to have within our firm to have capabilities to build also robotic subsystem and robotic arms. And also, when we put our roadmap on the map, when arcing out on LEO and having higher capabilities of power is just the first step. If you look on this slide, there is much more. But LEO is the closest environment, the easiest from technical point of view to execute. Still very difficult. However, if you go further, you have very large antennas. You don't have a telecommunication satellites, but you have permanent platforms, solar farms on the geo orbit. You have space stacks that are going from Earth to Mars and back, cargo ships. And of course, you have a lunar and lunar surface, which is very exciting here. So our story in Luxembourg started when you started to invest in Luxembourg a lot in so-called new space, we proposed to develop robotic subsystem, build a robotic subsidiary here in Luxembourg, and actually when we were searching for the market for finding robotic arms, we found out that for this subsystem, for this product, there's a lot of people, there's a lot of companies that are looking such a solution. So why don't build it by ourselves, use it by ourselves, and also sell to others? So we started to build in Luxembourg, design and produce STAARK robotic arms. We found out that there are several key components that are required that our clients are looking for. To have, for example, modular arm that we could adjust dexterity, to have like one package of modular elements we can easily adjust and build robotic system that it's cost, but it's a little bit adjusted to what client is looking for. So in the previous slide, I told that we passed PDR. Right now, we are going to manufacturing readiness review very soon to build our first engine models. Here you can see facilities we have in Luxembourg in Polvert incubator. We built our clean room. We have our thermal vacuum chamber to do tests in-house. We have our specific robotics test stand to validate performance and functionality of the robotic arm, which we are building right now. So we are right now in intensive campaign where in previous year we built breadboard model of the robotic arm. Here you could see on the left, on the right, something we are calling baby arm to validate first functionality of the robotic arm, and also to go very quickly to environmental tests to check performance in LEO space environment. So this summer we actually will be building and we will be testing full-scale engineering model of the robotic arm. Since maybe you have heard, we were looking for quickly demonstrate capabilities of robotics in space, ideally in LEO environment. So last year we get agreement with STAARK, in-space transportation company Momentus from California, where when this year we were granted to do here in Luxembourg phase 1 study for their satellite servicing mission using ARM, such as this one we are doing in Luxembourg. So next year, I hope we are very targeting. We are going very intensively to provide robotic subsystem to Momentus to fly probably at the end of the year with demo mission. So there is a lot of things to do right now here. And when we were doing our research on what might be application of the robotic arm, and our friends from Honeybee Robotics already confirmed this even during this call, there is an intensive need for these applications on LEO and probably GEO a bit later. The next step, or maybe very soon, depends how you look on this, is actually having robotic subsystem to support lunar mission. So here you can see pretty nice render from showing a STAARK on the lunar lander. So I must say we were, I think, a little conservative at the beginning of this application, since in the past we saw a lot of companies that didn't succeed in flying to the moon and delivering payload. However, if you track what is happening on the space resources utilization front, what you see in general on the lunar surface market, at the beginning it started from, I would say, interesting competition, privately sponsored, that built its credibility and its path to actually having commercial providers serving agencies to achieve their goals, first by doing robotics flight, and then, as we have heard recently, also delivering human and astronauts. Mostly on the NASA front, a lot on ESA front, and we are very glad about also on the Luxembourg front more and more with SRIC. What we found out that right now, I think even this year, we have 1 or 2 missions, unmanned missions to the lunar surface, I think done by Robotic. We found out that during these first missions, the developers of the lunar landers mostly are focused on, soft landing, not crashing, delivering what they promised, what they were paid for. But as a second step, as a second mission or third mission, robotic element, it's required to actually do the next step and perform all of this list we mentioned here. You are not able to do ISRU without having robotic subsystem, or you might do this having a simple deployable devices, but your outputs from these missions will be limited. So right now here we are oriented, we are focused on the, of course, Momentus mission, but our next step is actually to delta development on upgrade of existing robotic arm to serve the purpose of ISRU and all of these operations. We found out, we spoke with, I think, more than 20 potential customers, we call it Lunar customers, that said to us, yeah, this is something we are looking for, this is important. And so going further, there is a lot of changes I mentioned here. It's a growing market, very challenging. Of course, lunar environment, it's something not trivial, I would say, but it's a great opportunity here. So we are presenting here actually, should I accelerate?
Yes.
All right. Okay. So made in space, recently we were acquired last year by Redwire, that is acquiring more and more companies and going to be a public traded company through SPAC this year. So here in Luxembourg and generally you would be hearing less about made in space, more about Redwire, since we found out that this is something very exciting. There is business case behind this, but you need to have resources and expertise to actually execute this. So Redwire was built to actually build large infrastructure in space and also developing robotic capabilities. Here in Luxembourg, we are the only company within Redwire Group that is in Europe. So we are acquiring more. I can tell you more to gather all of this expertise that is required to execute these missions. We have on board companies that actually execute US missions too. I think for all destinations that exploration missions went. So this is something what we might have support here in Luxembourg. Thank you a lot. I think this is just the beginning. At least this is just the beginning for us. So we are very excited to work with everyone. We are looking for partners in front of so-called lunar industry. We are hiring here intensively. We have our internship in Luxembourg. Sorry for a little bit advertisement. So if you need anything, if you would like to work with us, if you would like to work in our place, if you would like to buy something from us, this is my contact. Thank you very much.
That's wonderful. You weren't the first. Yeah, absolutely. Thank you so much. There are questions too on the chat, but just because of time, I have to
maybe one.
Maybe one question. Okay, right. I'll pick one for you if I can. I'll throw to Patrick just in case you've got one, Patrick, on the line.
Yes. Yeah, Patrick, go ahead.
Yes,
no, go for it.
As well. I can hear you both. I can see there's a couple of questions, although most of the questions were about Irina Rashotko, who is still an unknown soul. I'm not sure she has become anything than unknown, but we know at least her name right now. But no, I'll throw to you, Patrick Advenit, one very quick question.
Very quick, yeah, we are getting a bit late, but the robotic arm that you're developing is being developed mostly for Leo at the moment. Have you dust-proofed it?
Could you repeat the question? Sorry, it wasn't so clear here.
The robotic arm that Made in Space Europe is developing, is it dust-proof? Have you done some work on that?
Very good. Very good question. We are investigating this because this is a very challenging topic, and I think our friends from Honeybee Robotics already underlined this, how it's important to be sealed here, since regularly it might kill everything inside, all the mechanisms that are rotating. So the current version of we call it Leo arm is not dust protected, but the next step under Delta development would be actually to to seal it. And even when working on this one, we are encouraging mostly mechanical engineers think about the solution in a way where we could adjust this easily to be dust protected.
Thank you very much, and thank you for that excellent question as well.
Thanks.
Thank you. So nice to have somebody in the room on the stage with me.